So here we are with another question on Zener diode circuits. So here we have this circuit and the information related to it is given. So a 10 volt Zener diode is used in this circuit to regulate the voltage across a variable load. Variable load means this load resistor RL. The input voltage varies in between 13 to 16 volt, and the load current, it varies in between 10 milliampere to 85 milliampere. The minimum Zener current is 15 milliampere. We have to find the value of this series resistance R. So here how to extract information from this. So a 10 volt Zener diode, it means that the Zener breakdown voltage is 10 volt. The input voltage varies in between 13 to 16 volt, and the load current, it varies in between 10 milliampere and 85 milliampere. It means that the minimum value of load current is 10 milliampere and the maximum value of load current is 85 milliampere. And another information is that the minimum Zener current is 15 milliampere. So here if you pay attention to this circuit, this is quite interesting. Here both the source and the load, they are variable in nature. Okay, variable source or input and variable load. So I've already explained in the first video related to solving Zener diode circuits, and in the various questions that we have so far discussed, that the input voltage or the voltage at the input side, the supply voltage, that affects the Zener current. Okay, when the input voltage is minimum, Zener current is minimum, and when the input voltage is maximum, the Zener current is maximum. Then another thing is that variable load, that causes fluctuations in the load current, that is IL minimum and IL maximum. Okay, this is when the load resistor is maximum, this is when the load resistor has a minimum value. Okay, and load current and Zener current, they are interrelated, as when the load current is maximum, the Zener current is minimum, and when the load current is minimum, the Zener current is maximum, like that. So we have already discussed these things. Okay, so here we have to correlate these things with respect to the given data. In the data which is given, we have only mention of the minimum Zener current, Iz min. So Iz min occurs when the load current is maximum, this. Okay, this. IL max is equal to 85 milliampere, which is given. Okay, IL max is 85 milliampere. Okay, this. Now taking these two, IL max and Iz min, when we apply KCL at this node, we know that the source current I is equal to Iz plus IL. In this case, it is Iz min plus IL max, which is equal to 15 milliampere plus 85 milliampere. Okay, this. That is equal to how much? 100 milliampere. 100 milliampere. That is the current. Okay, I is equal to 100 milliampere. Now here, if we apply KVL in this first loop, first closed loop, so here, as we are considering minimum Zener current, that occurs when input voltage is minimum. This minimum value of input voltage is how much? 13 volt. This. So we have to use these values which are within the boxes to determine the value of I. So here if we apply KVL in this loop, we have this. So here Vi minus IR minus Vz, it is equal to 0. That implies R is equal to Vi minus Vz by I. This is the simple equation. Okay, in normal cases we would have used this equation, but here everything is fluctuating, everything is variable. Input voltage is variable, load resistance is variable. So with respect to these two conditions, variable input, variable load, we have to use an appropriate equation using the appropriate value. So in this case, it is R is equal to minimum value of input voltage Vi min. Zener voltage is constant, that is fixed. The value of I using KCL is taken as Iz min, minimum value of Zener current, and maximum value of load current, IL max. This is equal to I. So when we put the respective values, we get R is equal to 13 minus the Zener voltage is equal to 10. 13 minus 10 divided by, we calculated Iz min plus IL max, that is equal to 100 milliampere. 100 milliampere. So this is volt, this is milliampere. So that we get 3 into 3 by 100, that is equal to 30 ohms. R is equal to 30 ohm. Okay, so here this is the important thing, to know which values to use. So you have to focus on the question. Okay, so when you see 10 volt Zener diode, it means breakdown voltage of the diode is 10 volt. Here minimum Zener current is specified. Okay, that is why we take Iz min. Then we have to use the concepts. Input voltage affects Zener current. Okay, input voltage affects Zener current. So minimum Zener current occurs when the input voltage is minimum. So here in this equation, input voltage, minimum value of input voltage will come into play. That is this 13 volt. Then another thing is that how Iz and IL, load current and Zener current, are related using KCL. So that correlation is important. That is, maximum load current occurs when Zener current is minimum. Minimum load current occurs when Zener current is maximum. So here, as Zener current is minimum, we have to use the maximum load current. Maximum load current here is 85 milliampere. So everything is dependent on this minimum value of Zener current. Suppose here maximum Zener current would have been specified. So in that case, when the maximum Zener current is specified, we would have taken the minimum load current. and maximum input voltage, that is 16 volt, and the equation would have been different. So here it is 30 ohm, the result of this circuit, which the parameter which we wanted to calculate. Okay,